A heat pump operating on Carnot cycle pump from reservoir at 300 Kelvin to reservoir at 600 Kelvin. The coefficient of performance is. So here this is the problem related with the heat pump. So for that purpose we have to draw a figure of that heat pump. So this is the heat pump. So this will be the hot source. This will be the cold source. And this will be the heat pump. So here that heat pump is power absorbing devices. So we have to work on the heat pump. So with the help of electrical energy we have to supply the work on that system. So this will be the W. So here we have to remove the heat from cold source and we have to supply to hot source. So that heat pump is used in winter season. So here we have to heat the room. So this hot source is what? Room. And we have to absorb the heat from where? Atmosphere. So we have to absorb the Q2 amount of heat, and that Q2 amount of heat we have to supply to that room with the help of that electrical energy. Okay, so that W will become Q1 minus Q2. Okay, as per the first law of thermodynamics, W is equal to Q1 minus Q2. So here in that problem statement they have given that heat in terms of that temperature, so we can replace that Q1 in terms of T1. This will be Q2 will be T2, so that W will be T1 minus T2. Okay, so here we can find out the efficiency, or we can find out the coefficient of performance. Here in terms of that in case of that heat pump, that coefficient of performance will be COP of pump is equal to output divided by input. So here in case of that heat pump, output will be what? Q1 divided by input will be what? W. So Q1 divided by W, that W will be Q1 minus Q2, and we can write that equation in terms of temperature, that will be T1 divided by T1 minus T2. So here that T1 will be higher temperature, this is 600 degree centigrade, or that 600 Kelvin. T2 will be 300 Kelvin. Okay, so we can put the all values here, that will be 600 Kelvin and divided by 600 minus 300. So coefficient of performance of that refrigerator, or coefficient of performance of that pump will be 600 divided by 300. So that 0 get cancelled. So coefficient of performance of that pump will be 2.